Okay guys, here we are on page 185 in your textbook, lesson 2 and chapter 8. And we're going to extend what we did on the last lesson. The last lesson we multiplied what was called a unit fraction. And so instead of just a fraction here, it would have said a unit fraction. A unit fraction is a fraction where the numerator is 1. So 1/2, 1/11, 1/3, things like that. So where the numerator is 1. And today we're going to look at fractions where it's not a unit fraction. So let's say it is 5/11 or 2/3. Right? So we're going to look at how to multiply a whole number by a fraction that's not a unit fraction. It's really not that much different from what we did in the last lesson. So let's just take a look at it. So here we have Alex drank 2/7 of a liter of water. Sophia drank 3 times as much water as Alex. How much water did Sophia drink? So again, in our diagram here, they've got a picture showing Alex as 2/7. Again, it's not really going to look like that. It's going to be something more like this when he drinks 2/7 of a liter. But we're going to show it in a bar like this. And then to show that Sophia drank 3 times as much, we take that 2/7 and we replicate it 3 times. Once, twice, 3 times. All right? So again, we know that this 2 blocks is 2/7. So Sophia drank 1 2/7, 1 2 more. So that's 4/7, 1 2 more. So that's 6/7 of a liter. So here's how they're going to show us to do it. First, they're going to do the same as they did last time. Remember, before this would have been 3 times 1/7 because we were just talking about unit fractions. Now, we still do the same thing. Again, I'm going to put a 1 here so that you can see that this 3 and the 2 get multiplied together. We have 3 sets of 2 here, so 3 times 2, all right? And then we're just going to keep the same denominator because this is 1 times 7. So 3 times 2 is 6. So we have 6/7. The other way we could do it is we could just add 2/7 plus 2/7 plus 2/7. We know from all our work with addition that when you have like denominators, you just add the numerators. So 2, 4, 6. So this would be 6/7. And again, here it's saying that 3 times 2/7 would be 6/7. Right? So this would say 6/7. Right? The other method, I can't remember what this girl's name is, Emma maybe. She takes and looks at it as 2/7 is the same as 2 sets of 1/7. All right, and then she wants 3 of them. So she's broken up this 2/7 into 2 times 1/7, which is what we talked about last time, that 2 times 1/7 is 2/7. So we're just breaking it apart. And then instead we're grouping this, all right, doing 3 times 2, our favorite old multiplying whole numbers. 3 times 2 gives us 6, and then 6 times 1/7 gives us 6/7. Right? So basically it's taking us from our new not unit fraction back to our old unit fraction by breaking that unit fraction apart and then multiplying. All right, so Sophia drank 6/7. Oh, that's her name, I think, Sophia, not Emma. Okay, next page. Page 186. So flip your page. Find the product of 4 and 2/9. And again, there's that word. Product means multiply. All right, so it's showing us we have 4 sets of 2/9. They just do that slight variation in color so that you can see here's 1 group of 2/9, 2 groups of 2/9, 3 groups of 2/9, 4 groups of 2/9. If we just count across, we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, or 4 times 2. So here's what they're going to do. 4 sets of 2/9. We're going to take, and again, think of this as 4 over 1. So we're taking numerator times numerator, 4 times 2, and we will get 8. And then the 9 times 1 becomes, or stays a 9. So 8/9. Okay, find the product of 5 and 2/3, right? So when it says, now just be careful because we've talked about 5 and 2/3 like that as the mixed number. That's how we would read it, 5 and 2/3. But here when it's got product in front of it, again, what it's telling us is get ready to multiply. And so when we see find the product of 5 and 2/3, we know that because we're getting ready to multiply, it's this and not this. All right, so you have to be careful when you're listening that you don't hear 5 2/3 and think this. You hear product and you think, I'm getting ready to multiply, and so it's 5 times 2/3. All right, so they've drawn this nice picture for us of 5 cakes or pies or whatever, where 2/3 of them are there. All right, so we can see 2 out of 3, 2 out of 3, and so forth. And then they group them all together. All right, so we're taking 1 of the thirds from here and making a full pie. We're taking 1 of the thirds from here and making a full pie. We're taking 1 of the thirds from here and making a full pie, and then there's 1 of the thirds left over. But let's see how that looks when we do it out in, symbolically. So again, we're going to do 5 times 2, right? 5 times 2 is 10, and then the thirds. And clearly that's an improper fraction. If we did not have those to look at, we would not be surprised to get that. Or maybe I should say, because we have those to look at, we're not surprised that we get that. All right, then we have to say, well, what is 10/3? In other words, how many groups of 3 can we get out of 10? So either you can just think about it, or you can divide like this. 3 goes into 10 3 times. So that's how many full groups that we can have, and we confirm that that's what they got in the picture. And then when we do that, there's 1 left over. And that 1 is that 1 extra third piece. So this is 3 1/3. Okay. I hope that if you have any questions, you're going to stop and you're going to rewind and watch it again, or ask your mom to explain it, or your dad, or send me an email and let me know that you need another part explained. Okay, find the product of 4 3/4. This is like that other example we did in the last lesson, where they're using a number line. So now each jump is 3/4. Remember, before it was just a single, I think it was a single third. But here, 3/4, you can see that they've taken that 1 and broken it down into 4 equal parts. And their jump is 3 of them. All right, so that's 1 jump. So remember, we talked about in that last lesson that maybe it was 1/3 of a meter, I think. If you could take a step that was 1/3 of a meter, and how many would it be? This time it's 4 times 3/4. Maybe this is like your dad's step, that he can go 3/4 of a meter when he steps. 3/4 of a meter, 3/4 of a meter, 3/4 of a meter. And it's asking how far will he walk in those 4 steps. All right, so again, from a visual perspective right here, we go all of those combined, 1, 2, this would be 3 down here that we would get to, all right? 1 whole meter, 2 whole meters, 3 whole meters. From a symbolic perspective, we're going to go to 4 times 3, and then we've got 1 times 4. 4 times 3 gives us 12, and 4 is 4. And then this is improper, and so we have to change it into a mixed number. In this case, there's not going to be any extra parts left over, because there are exactly 3 groups of 4 in 12. So this would be 3. So that confirms what we got right here. Okay, last page, page 187. May is stapling 5 paper rectangles end to end on a bulletin board to make a border. Each rectangle is 7/8 inches long. How long is the border? All right, so this is a little bit more visually distracting than the last one, because they've got all these tiny numbers, but let's look at this. This is 0 to 1 inch. That makes this a 1/2 inch right here. Halfway between 0 and 1/2 is 1/4 of an inch. 1/4 of an inch. Sorry, this should actually be 3/4 of an inch. Then halfway between 1/4 and 0, this is 1/8 of an inch. That means that this is 3/8 of an inch. This makes that 5/8 of an inch, and that makes this 7/8 of an inch. And so you can see right there where it ends up as 7/8 of an inch. And then the next one is placed right next to it, and so forth. Right, so it's not quite as easy to see as it was in the last one because of all the extra markings. So 5 times 7/8, again, we're going to do 5 times 7 over 8. 5 times 7, 35 over 8. So it's asking how many groups of 8 can we get out of 35? And again, if you can skip count in your head to figure this out, you don't need to write the division, but I'm just going to do it just in case you want to see that. 8 goes into 35 4 times. 4 times 8 is 32, and there's a 3. So this tells us that we get 4 whole groups of 8, which would put that as our whole right here. And we can see that, yes, it went just past 4. And then there are 3 left over. 3 what? 3 eighths. All right, it's always, that denominator part is always going to stay the same as it was in the beginning here when we convert from, or not from the beginning here, from right before, from our improper fraction step. It's always going to stay the same because we're always talking about the same size piece. It's just here it tells us that we can make 4 whole pieces, and this says we have 3 pieces left. What were those pieces? They were eighths. All right, so the border is 4 3/8 inches long. Okay, so now it comes time for you to practice. So let's just do 2 of these together, and then I'm going to ask you to pause the video and come back. So we're going to multiply across. 2 times 2 is 4. 1 times 4 is 5. This is not improper, and it cannot be reduced, so that's your final answer. All right, let's do A and C because I want you to see one where you're going to have to either reduce or get an improper fraction. So let's do 3 times 2 is 6. 1 times 9 is 9. This is not improper, but it can be reduced because 6 and 9 both share a factor of 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. So the final answer there would be 2/3. All right, so again, remember, any fractions that can reduce, you have to reduce them. If it's an improper fraction, you have to change it to either a whole number or a mixed number. And sometimes you will have to do both within one problem, mixed number and, improper fraction and a fraction that's not reduced. Okay, so come back when you're done. Okay, hopefully you did all right with that. Let's just go through and do them. 2 times 3 is 6. 1 times 7 is 7. That is the final answer because it's a proper fraction and 6 and 7 don't share any common factors. All right, 5 times 3 is 15. 1 times 4 is 4. That's an improper fraction, so we need to change it to a mixed number. So this is asking how many groups of 4 are there in 15. There would be 3 groups of 4 because 3 times 4 is 12. If we go 4 times 4, we get 16. That's too much because we only have 15. So from 12, there are 3 more pieces that are left. So this would be 3 3/4. And again, if you don't like that, you can do this. All right. Okay, now we're going to go through here. 2 times 4 is 8. 1 times 8 is 8. 8 over 8 is just the same thing as 1. Because again, that means that we have pieces that are called eighths, and we have all 8 of them, and that means that we get one whole circle filled in. Okay, 3 times 5 is 15. 1 times 2 is 2. 15 divided by 2, in other words, how many groups of 2 can we fit into 15? Or can we get out of 15? That would be 7, because 2 times 7 is 14, and then there would be 1 piece left over, so 7.5. All right, letter G. 6 times 3 is 18. 1 times 4 is 4. You should have done 18 divided by 4 because you're trying to find out how many groups of 4 there are in 18. There are 4 because 4 times 4 is 16. That means that there are 2 pieces left over, so 4 2/4. All right, and then 2/4 can reduce because both 2 and 4 are even, so they share a common factor of 2. So that becomes 4 1/2. All right, letter H. 3 times 4 is 12. 1 times 5 is 5. Improper fraction. So we convert it. There are 2 sets of 5 and 12 and 2 pieces left over. Okay. Again, I still feel like these are much easier than adding. Hopefully you're feeling the same way. All right, let's take a look at this word problem. A bag of broccoli weighs 3/4 pound. Janice bought 3 bags of broccoli. How many pounds of broccoli did she buy? All right, so again, since this is repeatedly adding 3/4, we're going to do 3/4 times 3. All right, I'm going to put it over 1. So we get 3 times 3 is 9. 1 times 4 is 4. And then how many groups of 4 are there in 9? There should be 2. And then that would bring us up to 8 fourths, so then there's 1/4 left over. So she bought 2 1/4 pounds of broccoli. Okay, let me know if you have questions. Bye.